Yes.
You did?
Yeah.
I think I was gonna do, I think I was going to do, what's October, November,
2007.
2006. Okay, did anybody actually try them?
I did.
Yeah?
I have this one, the other one.
Yeah? Yes, no, maybe so? Okay, let's see what we got going here. Okay, so the diagram you see is just like the one hopefully you see on your thing, October, November 2007. Once again, was there anybody that had a star with EC on their test by their extra credit choice problem that didn't put their name on the test? No?
Will you be here Friday?
Friday morning?
Friday morning? Can I come in and take the...
Yeah. All right. They're still supporting a 0 until I can find a name for it.
Is that like a hyphen too?
Which one is it?
It's definitely not a 0.
I'll take credit for it.
Yeah, imagine. It's a nicey. It's a good one. I have to find it. Did you take the test there?
I don't remember.
It looks like this. It says, in the diagram, AB is an arc of a circle, center 0, radius R, angle AOB is theta. The point X lies on OB and AX is perpendicular to OB. Okay, and then it says, show that the area of the shaded region is given by, and then they give you the answer of the area. So the area they're looking for, and remember your answer has to look just like this. Okay.
Do you have an extra copy of
I have one more left up front there.
that? I have it at home, I just put it on.
Okay, just give it back to me when you're done. Okay, so let's think out loud for a minute. When I see sines and cosines in my answers, or tangents even, I know previous to getting that answer, what would I have been working with?
Wait, say that.
Okay,
Yeah.
when I see sines and cosines and tangents and these types of answers, what would I have been working with before to get that answer?
Be finding the signs in this triangles, but we can check this out.
So say it again, you've been talking about
You're gonna be finding sides of triangles.
sides of triangles, so the key word I'm thinking right now is triangle. So you're thinking sides of triangles, and you're looking at sides and angles in order to get the word sines and cosines, right? Does that make sense? So the thing that I need to think about is, do I have a triangle in this problem? Okay, so perhaps I need to utilize the triangle to try to access the word sines and cosines. I'm trying to give you some game plan to try to figure out how to attack these, okay? So if I'm looking at this, do I have a triangle in this problem? Yeah, I do, right? And I actually see a really nice right triangle, which is very, very good, okay? Do I have a reference angle that I would be working with?
Yep.
Sure, and we call it here theta. What else do I have? I have R, very good, I have R. Okay, so is everybody comfortable with what I just said? So I'm trying to figure out a game plan and things that I can utilize in order to try to get that kind of answer. So this thing says it wants me to find the area of the shaded region, okay? So if you're looking at it, the shaded region was this stuff right here, alrighty? So the thing that I typically would do to find the shaded region of something that's not like a triangle or it's not a shape that we're familiar with is we have to use other shapes to try to get to it, right? So does everybody see that this is your circular sector, slice of pizza, and this, right, is your right triangle. So it would make sense that if I took the area of the circular sector subtract the area of the piece of pizza, I'm left with the stuff I'm looking for. Does that make sense?
Yeah.
So we're looking for the area of the slice of pizza minus the area of the right triangle. Everybody cool with that? So let's kind of fill in the blanks here. How do we go about finding the area of the piece of pizza? Remind me once again what the formula for that is? Yes.
It's 1/2 r squared theta.
Okay, so the area of the slice of pizza is 1/2. Well, what's r in this case?
Just r.
It's actually just right, it's r. So 1/2 r squared, and then what is the angle in this case?
Theta.
Theta. So it's really not creative. They're giving us the actual formula stuff. Does that make sense? Minus. How do we go about finding the area of a triangle? What's the formula?
1/2 base times height.
1/2 base times height. Perfect. Well, B and H, base and height, are not what we're going to be looking for as far as the answer is concerned. We actually have to find the B and H, right? So does everybody agree with me that the thing that is not the hypotenuse will be the B and the H? So the base and the height is what we're looking for. Are we good? Okay, so how do we go about finding, for example, the height of this thing?
You would do the you do sine of theta equals ax over r,
Okay, tell me why.
because you have what r is and you're looking for ax.
So you're looking,
Yeah.
there's my opposite, right?
Uh-huh.
There's my hypotenuse. So those things bring sine into the picture. So you're saying sine of theta is equal to opposite, which we now know is ax, over the hypotenuse, which we know as radius. So far, so
Yep.
good? So, no, yeah, maybe? You good? Okay, so what is ax, if we clean that up a little bit?
R sine theta.
R sine theta. Really, this is R sine theta. Perfect. So height is R sine theta. Perfect. Now what about base?
Cosine.
Because this is adjacent, right?
And there was also cosine in the answer, so you knew you had to use that.
You knew you had to use it. So you see, you look at the answer and you go, okay, back up a bit. What would I have done to get there, right? Use your logical thinking there. So cosine of theta is equal to OX over R. Everybody cool? So the actual base here is R cosine theta equals OX. So R cosine theta. So far, so good? Now, if I look at the answer that they're looking for, the things that I should have are the R, sine, cosine in terms of theta. Yes, go ahead.
Could you take the R out of both and just put it in the front and both of them to just no.
Yeah, like you could take these two R's and make them together. What would they be if you pull them together? So let's do that. 1/2, good job. R squared theta minus 1/2 R squared, and then cosine sine. So far, so good. Now what do you see?
Factor out.
You can factor out what's in common, right? So we're going to factor out what's in common? 1/2 R squared. 1/2 R squared. So I'd have theta minus cosine sine. Is that okay if it says cosine sine instead of sine cosine?
Yes.
Does anybody remember what property that is? Yes.
The identitive property?
It's one of the properties, not called identitive, commutative property of multiplication. AB equals BA, yeah. Yes.
What did we just do?
We just recognized that they both had 1/2 R squared, and so we factored it out. And what's left over is theta minus that stuff. All right, how many points did we earn? We earned 3.
Let's go for 4 more.
Let's do some more. In the case where R is 12 and theta is pi over 6, find the perimeter of the shaded region, leaving your answers in terms of square roots of 3 and pi. So what does that mean to me?
Radian?
You gotta keep the ugly stuff.
Keep the other stuff, no decimals, no calculator action here, okay? More like the unit circle stuff.
So is it radians or?
It's going to be in terms of pi, so it won't even be a decimal,
Oh,
okay? So what did they tell me specifically is that R is 12, given now. R equals 12, and So what? OB is 12. Okay, yeah, good. OB is 12. And what was theta?
1/6.
1/6. So pi over 6? All right, cool. So it wants me to find the perimeter of the shaded region. Perimeter of the shaded region consists of this, this, and that, right? Okay, so let's do the AX first. So how do we go about finding exactly value of AX? Yes.
You sign.
Because what it was AX in the first place, AX was R sine theta, right? So AX is going to be 12 sine of pi over 6. Okay. How do we figure out sine of pi over 6 pretty easily?
Well, let's see, the sine is the y value on the unit circle for the, and then so, yeah, you just use that value for pi over 6.
So yeah, at pi over 6, the sine is 1/2,
Mm-hmm.
right?
You need to find
Good
OX.
job. Okay, let's keep going, yeah. So this is 12 times 1/2. So far, so good.
Mm-hmm.
Next, we have to find the pizza crust, right? The arc length. What's the formula for that?
Well, it's R times theta.
R theta. Okay, so 12 times pi over 6. We could clean that up to be 2 pi. Good. Excellent.
And then you have to find OX because then you just subtract that from 12.
So you're saying because this whole thing is 12, if we found OX, we subtract it, we'd be left with that little piece there. Good, makes sense. So how do we find OX pretty easily?
Cosine, that R cosine.
We've already done the work for it, right? So can I do it this way? Can I do 12 minus OX, which is 12 cosine of theta, which is pi over 6. Does that make sense?
Yes.
So that whole thing is what we were looking for. The whole thing is 12. We're going to minus that. That's what's left. So now, remember, the final result has to be left ugly. Square roots, pi's, those kind of things. So what is the cosine of pi over 6?
33 over 2.
Okay. So cleaning her up here, I got 6 plus, you guys told me 2 pi, plus 12 minus 12 times, you just told me what? Square root of 3 over 2, right?
So then we just use 6 square root, or 12 minus 6 square root, or 6 square root of 3.
You gotta combine the 6 and 12.
Yes, bless you. 6 and 12, 18, plus 2 pi, minus, that goes in as 6 square root of 3. That would be sufficient.
But you still gotta get it into, I think it was just pi in terms of square root of 3, right?
No, just that's the far as you
But
can
you
go.
can go further. If you turn 18 into 2 times the square root of 3, right? Or square root of, wait,
Well, you
Yeah.
can't.
no.
3 square
It's
root
you
of
factor
2.
out
6 times 3.
6 over 3. Can't you do that?
Well, let's look. That's a good thought process.
I thought it had to be in the
9
square
times
root to turn it into.
As long as those are part of your answer. So wait, this is like 9 times 2, which is, that's 3 times 3. So the square, but you wouldn't want to just square root it unnaturally. No, no. So no. That's it.
You just
I
do
thought
it
you would only do that when the 18 was in the square root.
That's what I'm saying. That's what I was just saying. Yeah. Yes.
For some reason, I got 18 plus 2 pi plus 6 times the square root of 3. So, like, everything was right. There was only plus square root of 3 instead of minus.
Okay, so does it make sense that this whole thing is the 12 radius
Yeah.
minus this piece here, which is this, yeah, 6 square root of 3?
No.
How'd you get that? Oh, because of.
No, we didn't finish, like, 12 times square root of 3 over 2. And then you combined it, yeah.
Okay, good.
Because what I did 12 plus 12 plus 12 times 1/6 pi minus 12 plus 6 times square root of 3 plus 6.
Oh, I gotta look at that. The next one I told you to do is October, November 2009/11. Okay. I like that. The picture is kind of crazy. And then there's one more that I've got to find somewhere in the archives of I'd like to do it. I'll find it while you guys work. Wow, look at that. Here we go, shading. Okay, so the diagram shows a semicircle. So what does that tell you about AC?
What's the diameter?
It's a diameter, right? It's half that. The diagram shows a semicircle with center 0, radius 6. The point B is such that BOA is 90 degrees and is an arc of the circle with center A. Find the length of BD. Okay.
So would you draw a line from A to B
I would. Why would you do that?
to make it an arc when?
So you do the line from A to B. You not only have a right triangle now and there somehow you might be able to
That
use,
looks like the exact thing that we
but you have, yes, an isosceles triangle. But you also have the,
arc.
yeah, and a piece of pizza, right? In there? Yeah.
But we have to find O to D.
Okay, so you have to find O to D. All right, cool. What do we do?
You know that BO is 6.
You know BO is 6, okay. Can you explain why?
Well, one's isosceles, 2 is the radius, and I said that the radius is 6.
Because all the radii are the same. Okay, good. Excellent.
And OC is also 6.
And OC is also 6. So from here to here, we have 6. Excellent.
So it would have to be like
So we know that's a little
6
smaller,
times
right?
OD.
Can you just find the length from A to B, and then just find the angle of the A part, and then find the what's it called, length of the arc?
Say that again?
Find the length of AB, that line, the line we just made.
Yeah, okay, we can find length of AB.
And
Okay.
then find the theta of A and B since it's isosceles,
Yes,
and then you find the arc.
okay,
Can you just do
because
it that way?
R times
And
theta.
if we-
Okay, let me ask you this. The length of AB is equal to the length of?
AD.
AD.
Right, does
So
that
it's
make
just
sense?
easier.
Okay, all right, so we can use the Pythagorean identity, right? Pythagorean. What is it? And does it tell us it needs to be left in any kind of,
Yeah.
so we're okay, all right, we're good.
Well, it's a square root of 72, right?
So,
Yeah.
right, yeah. And I think that's how the mark scheme left it, with the square root, ugly square roots. So 6 squared plus 6 squared equals 36 plus 36, which is 72. We're looking for the square root of that. So this really, and let's clean that up. What is the square root of 72? What is it?
6 squared 2.
6 square root of 2 is
Which
36.
makes sense because it's 1, 1.
Yeah, 1 square, very good. All those good reasoning skills y'all have going on. Excellent, yes.
So now we also know AD is 6 times the square root of 2.
So we also know
Just minus this.
this is 6 square root of 2. Good, excellent.
We don't.
We're not finding
Yeah,
those.
we don't do that.
Maybe we will in a minute.
That's the radius now.
That's the radius, yeah, go ahead.
determined that that was also 6.
Okay, because do you see that the piece of pizza is that? So you see from here to here is 6 square root of 2, so therefore from here to here is 6 square root of 2. Does that make sense? Cool. All right,
And
now
then
what?
we just do
We
the
need
whole
to do
thing.
radius times theta.
Because we're looking for the length of the arc, right? So it's, arc length is r theta. So 6 square root of 2 times, oh, what is that? You guys told me it's an isosceles. Yeah. So if I know this is 90,
And that's 40.
Pi over 2.
I know those are 45. Now, I would prefer to leave them in terms of pies instead of degrees.
Pi over 4?
So pi over 4.
Yeah.
Good job. Look at Jake. Wide awake and answering questions. Yes.
Because all of the angles have to add up to pi.
Correct. Correct.
So,
180,
because the 90 is pi over 2, so then that would mean that you've got pi over 4 and pi over 4.
Which is 2. yeah, 2 pi over 4, which is pi over 2, plus pi over 2, which is 1 whole pi.
Because it's an isosceles, so then those two angles have to be equal to each
Right.
other.
You're right. Okay, so this is times pi over 4. Okay.
Why, is that just a personal preference for the pi?
Well, the reason why I say that is because, I mean, this one had a degree on it. Did anybody look at the mark schemes? Did they,
Mm-hmm.
I
I
think,
looked it up, but I couldn't find it.
I think they did it in, oh, you didn't find it?
I looked on the extreme papers, and I just couldn't find it.
Yeah. I think they had no degrees. I think they had radians.
Oh.
Yeah. But
But
they
they
won't
have
mark,
it either way,
they
right?
won't mark it wrong.
Yeah.
Yeah.
Unless it's just.
Unless they said 3 decimal places or in terms of pies or, so I'd be careful though, okay?
Could you simplify that?
Yeah, I would. I know that 2 divides into both, right? So what do you have?
Square root of 2 pi.
3 square root of 2 pi
Over 2.
over 2.
Leave it like that?
Yeah. Not pretty, but it is. Okay, so there's one answer. And then the next one is find the area of the shaded region. So you're going to find the area of the piece of pizza minus the area of the right triangle.
Mm-hmm.
Does that make sense?
Yes.
How do we find the area of a piece of pizza? The formula is
1/2 r squared theta.
1/2, what was r?
6 times the square root of 2
Squared, and then theta pi
pi over 4.
minus the right triangle area. 1/2
6 times
base
6.
6.
times height.
Okay, I have a question.
Yes.
Since that is your new radius, is that equal to 6? Like, could you say that since that was your original radius, or does it change?
It changed because we moved the center of the circle to like all the way to A, and we made a new circle. So technically, you can just forget the curve from A to B and the curve from B to C and then C to D. You just forget that.
Kind of forget it's there, right?
Okay, you made a new circle.
Yeah, yeah. Like this guy would go all the way around as a circle within that circle. Yeah. Okay, so this squared, those are the, that remember, the 6 gets squared, then the square root of 2 gets squared. So you would have 36 times 2, right? So what'd you get? 72 times pi over 4. 6 times 6 is 36. Half of that would be 18. Half of this would be, what, 36? Divided by 4. 36 divided by 4.
9.
9 pi minus 18.
You know, leave it at that? or
Yes,
is it-
I would. Unless otherwise told. Yeah.
The mark scheme said it was acceptable to have 9 pi minus 18 or 10.3. So
Thank you. So you found a mark scheme somewhere. And again, they're not going to be. Now, if that's the case, what that tells me, if the mark scheme told him that it was acceptable to have that, they did not leave the other angles in degree form. So let's go ahead and make like a conscientious effort of trying not to have degrees, even though they said 90-degree angle. Yes.
whenever you're doing these types of problems, should you just leave your calculator in radians and just assume to always use radians unless
I would.
otherwise
I
stated?
would.
Yeah.
Yeah. And I know you're just stretching out. I know. Getting ready for the next one. Getting ready for the next
Did
one.
everybody sign it?
Whoa.
Which one are you doing?
The next one was
The last one.
the last problem on the whole thing, I think.
That one was confusing.
Is it good?
13.
Yeah.
It's a good one to do, though.
Mhm.
If it's confusing, I want you to do them now instead of during a test, right? Find confusion before you have to try to do it yourself. Okay, the picture's not doing it justice. Sorry.
The other ones are pretty good.
I've done pretty good up until now.
So my picture to draw.
Oh,
Yours looks more like a kite.
thank you.
It should be.
Is that a compliment?
No, it should be a rounded.
Oh, perfection. Still love you, Lance.
You know what it kind of looks like? The Sims diamond.
P, Q, D, A, B, C. What does this mean to me when they do this?
They're all equal.
Oh, good. You're all on the same page.
Which
Okay.
means that
So you're looking at one that's a little better than the drawing I have, but at least it's something we can play with up here. The diagram shows a rhombus ABCD, points P and Q lie on the diagonal. Yes.
Just right.
So what do I know about if something lies on the diagonal? Like for here, what do you know about this here? It's midpoint, right? Right, midpoint. And what do we know about from here to here?
Midpoint.
Also midpoint. Very much not true to scale here. What's that?
From where to where?
Like the halfway mark
Yeah.
is a midpoint, and that's a midpoint.
Oh,
So
for that one.
just kind of think about that.
So you can draw a line from here.
It's so each of these are the arcs of the circles with the center C, and BQD is an arc with center A. So what they're trying to say is this piece of pizza is the center of the circle. This piece of pizza, there's the center of the circle.
So they overlap.
Correct. Each side of the rhombus has a length of 5 centimeters. Well, that's kind of nice. So 5, 5, 5, and 5. Yeah. And then BAD, bad, is 1.2. So BAD is 1.2. Radians. So what that means, what does that mean to us when it says 1.2 radians?
And we don't have to worry about pi.
We don't have to worry about pi, right? They actually converted out of pi. They did 3.14 times. Yes. So,
Draw a line
draw a line.
from B to D.
Okay. So I'm going to do it in a different color. That way we see maybe.
So you're finding B,
So-
P, D, Q, so you're finding shaded regions?
So you find the two triangles.
Tell me what you know about. Tell me what you know about that red line and the line AC.
That they're
Perpendicular.
Perpendicular, so they're 90, right? So this is 90 degrees, right here. That's 90, that's 90, that's 90, right?
Yeah.
I don't want that many of them, but you understand, right? So, yes.
Okay, so, if you wanted to do, because Lance mentioned it last week, I mean, not last week, this week, but I don't know if it's the same thing. But you have to read the angles are the same on the opposite.
oh well, like BAC and DCA are the same angles, or the Z thing I was talking about.
Is that the
The
same
other
thing?
one's BAC.
So like BAC.
What is BAC?
Is half? Is it half? I know. Does it tell us?
Yeah.
What is it?
Well, doesn't those AC is like a bisector, so then it divides each of those in half. So it's
So-
0.6 and 0.6.
That's right.
Yeah.
Does that make sense?
Does that matter?
Yeah. Oh,
Yeah.
yeah. Let's see why it matters.
Well, you would find.
So what do you have with that? Do you see here? Here, here, here? What do you have?
A right triangle?
Right triangle, right? So what are the things that pop to your head?
Already, so you just have to.
Oh, okay.
You know that you have a side, you have an angle, so therefore, what could you find? You could find this side, you could find that side.
Uh-huh.
We don't know what we need yet, because we haven't really read what we need, but we know we find a lot of things. What?
At least that was.
You were what?
Because you know, all you have to do is find the two big triangles, which they'd be the same because they're all congruent.
Can you find one and multiply by 4?
Yeah.
Well, yeah, I mean,
Yeah, because they're all the same. All the sides.
Is that what you want me to do?
no,
No.
Yes.
the big triangles.
Yeah, like
So there's two of them in each.
BAD.
So BAD is one,
Okay.
BCD is one.
So you
Oh, I
want me
see
to
what you
find BAD?
Yes.
Oh.
Not the angle. but
Triangle.
the- Yeah, the triangle.
Okay.
And then you find the arc area of BABD and then the arc area of CBD, and so you add them. So if you get the areas of the two big triangles,
Yeah.
you get the area of the whole thing,
Okay.
right?
Right.
And then if
Just
you
subtract.
when you subtract, you have the.
Okay. Don't you just need one of the triangles and then one of the whole arc? And then you take the arc, subtract the triangle, and now you have half the shaded region, and you just double it to get both.
Yeah, that's.
So what he's saying is find the area of a triangle, right? You could actually double it and you have the whole thing.
That's what
Okay.
he was saying.
Yeah. Find the area of the arc, take away the triangle, what's left? This stuff, right? And then you multiply it by 2, because it's going to give you that next piece over there.
I just don't see why you have to do one side and double it when you can just do the whole thing.
Either way, it gets you the same spot.
Alright, let's do it.
Okay, let's do it. So, how do we find the area of the triangle? The reason why I think you should cut it into 4s is you find an area of the right triangle really easily, because it's 1/2 base times height, right? So what would these sides be? How do we find that? For example, how do I find the
So are we
base?
finding
You just do this sign.
Yeah.
Sign of it.
Sine of
BAD.
0.6.
Are we finding that?
Because from here, we get this is opposite, this is adjacent, that's hypotenuse, yes?
Yep.
6
So,
equals
X over 5.
so sine of 0.6 equals opposite, or
BQ.
be whatever, right, over 5. So,
5 sine 0.6.
Ms. K, can I have Jake for checkout?
he's on his way.
Thank you.
So plug that puppy in your calculator, and what do you get? Make sure you're in radian mode.
If I get down to like,
Anybody?
Why is it over? I get 8
Opposite.
of it 2.823.
You got what, 2.823? Is that what you said?
Yeah, 2.823.
Okay.
Yeah.
Now, how do we find the height of that triangle?
Cosine. Or you do A plus
0.6, bless you, is equal to the adjacent over 5. Bless you, bless you, bless you.
Thank you.
So 5 times the cosine of 0.6 is equal to the height